there will be sort of governance minimization, which is the prior approach that I was describing, or you can say that there'll be community governance, whether essentially a DAO or something similar, or perhaps a non-coin voting DAO, so an identity voting DAO, something like that, controls the content that should be displayed in a single community's pocket of a website, like a subreddit or something like that. That's completely possible inside the system. And the exciting thing is that that community is sovereign. The code that you could say describes how that community should be able to essentially govern their space is concrete and immutable, and then the community is the highest governing body of that area. There is no company that can come along and change it from above. They are the people that run what happens there, which is really powerful and very, very different than the centralized web that we currently have. So you can also, another, would you say, aspect that is highlighted by this essentially approach to building web applications, which are decentralized by their nature on the permaweb, is that users can trust the application in a way that they really can't with the Web 2 kind of world. So in Web 2, we see this application lifecycle where an application starts free and it is increasing in quality, essentially. This leads to, or this is particularly like at the early stage when like a founder comes along and they build something over a weekend or something like that, and they put it out into the world, and then suddenly people start to use it. And that's really exciting and great. But the problem is that they are accruing more costs linearly with the amount of people using their application. And so what they end up having to do is go to venture capitalists, typically take capital into the company. And so they bankroll this process of the second stage market capture to the point where they have essentially market domination, and then also you could say lock-in somehow. So some sort of wall around the garden, if you will, where it's not easy for people to take their data out or to take their identity out. So in the case of Gmail, for example, if you've got a Gmail address, you can't take your identity somewhere else because everybody knows you by your sam@gmail.com or whatever it is. Yes, you can't easily leave. And then after that, the company can perform the final stage, which the founders, whether they like it or not, will be forced to do because they've taken that capital during the second stage, which is market domination and profit maximization. So just extracting as much value as they possibly can from this thing that they've created. It's pretty sad, really. And with permanent web applications, we do something very, very different. So if the application is available in a certain form at the beginning, that application cannot be taken away from the user. It respects what we might call like a consumer integrity. This idea that what you see is what you get forever. And it can, the developer can release a new version of the application, but they can't take away the old version. If you want to keep using the old version, you can. And now the power relationship between developer and user is fundamentally different. Now the developer cannot play this game of the Web 2 app lifecycle. Instead, they simply have to make the thing better. And each time they release a new version is it's a negotiation, if you will, with their users as to whether they upgrade. So if they want to add, something that maybe distributes profit to a token associated with their application, then they absolutely can. But they have to make sure that that release is sufficiently better that the trade-off is such that users actually want to use it rather than using the previous version. And so it almost, as a result of being a very blockchainy system in some way, transfers the properties of blockchains into the sphere of web applications. It's kind of fundamentally different. So another thing you can do, and a reason you might want to build a permaweb app, is to build with open data. So in the Arweave universe, all of the data is in, if you will, like an open data lake. So Verto, Mira, Agora, these are all applications built on top of Arweave. Their data is all on Arweave, and you can access it just as much as those applications clients can in your new application. And this changes, again, the game in terms of web application adoption. Because, of course, when you're building a new web application, there's this fundamental question of, well, how do I bootstrap content typically? Like if you look at the Web 2 space, it's dominated by platforms that one way or another connect users to some form of content. And content providers have to be found somewhere, even if that's like literal traders on Amazon or eBay. They're still kind of providing the content for the platform one way or another. Well, on the permaweb, you don't need to bootstrap in the same way because all of the data from other applications is available. And so you can just build a client. And so, these three applications here, they all use in various different ways data protocols on top of Arweave, which you can just plug into. So you could, Agora is something I'll show you in a little bit. There's basically a public square, like a decentralized Twitter on top of Arweave. You can just build a new client and tap into that data, and it just works. Same with Mira. You can get all of the Mira posts. Someone actually did this recently. They built an alternate client to Mira back when I think Mira had like closed beta sign up, something like that. You can access the application's data and you can just go run with it. There's permissionless innovation on top. So it leads to this, let's say, much faster spin up time when you want to build a new application. You can also, another like an interesting facet of these applications is that they have zero maintenance. So one of the ways that you can think about perm web applications is that they're dissociating application source code from application state and also sort of application rendering. So on top of Arweave, and this in a typical web application is kind of all bundled together, right? So the server that runs the application has the source code on it, yes, but also it's kind of doing some sort of serving of it one way or another to the user, which we would say is the kind of rendering step in some form. And then it's also got the database inside, or whatever kind of data writing you're using inside that same server. But with Arweave, as the developer, you write the source code onto the permaweb once, and it costs you like 0.9 cents per megabyte. So for most web apps, like a quarter of a meg or something like that, we're talking about like 0.2 cents to store your application forever. You don't need to pay for it again afterwards. Instead, what happens is when the user wants to get a rendering of that application, they either plug directly into the network and they trade their bandwidth around like you would in BitTorrent, or in more likely case, they just use a gateway, which they have a financial relationship with one way or another, kind of like an ISP. I mean, we offer a free one for now, but we expect there'll be a big ecosystem of these over time with like different performance uptime and different business models, pay as you go, subscription, whatever it happens to be. But that person, that gateway is going to animate that application for you essentially, and then serve it back to you. And your web browser will render it. And yes, you can you can access the application's data from the network itself, essentially as a database through this gateway service. And so as the developer, you don't have to do anything for this. You pay zero fees after you upload the source code. And so when you're thinking about like, side projects, fun little things you build on the weekend, well, it's like you either deploy on Amazon or something and you pay $7 a month for the minimal server forever until you just like forget, to update the server, you forget to pay the bill or whatever it is, and it disappears. Or you just pay like 0.2 cents, it's on the permaweb forever, you never have to think about it again, and people can make use of it. It's like your application has become a public utility. It's pretty cool. So this is essentially how that works. The developer pays once to store the data onto Arweave, and then the gateway is the thing that exposes that as an application, if you will, to users. And then the user and the gateway, they have some sort of relationship financially that makes them make sense. And yeah, right now it's that we, the Arweave team, have a huge incentive to see Arweave get adopted, and subsequently we're very happy to see people. We're very happy to see people, if you will, using the software. So we're happy to pay for the gateways, or at least some gateways. Although there are now many more gateways spinning up in the network that we don't pay for. So that's cool to see. We expect that ecosystem will spread over time. Okay, so how do you build on top of the system? Well, if you can build a simple JavaScript application, which I assume essentially all of you in the audience here can, then you can build on the permaweb. Like, it's really not very complicated. We've actually tried to make it so that it's the exact opposite of what you find when you're like trying to start building in the blockchain space, which is everything is new and different and a little bit more complex than you previously, learned in and expected it to be. We've really tried to make it so that anyone that can build simple JavaScript applications can build on top of the system, and it feels kind of natural, using the same frameworks that they're used to and everything else. Build as normal, but instead of user accounts, use Arweave.js to interact with the user's wallet. So there's a system here called rconnect. The user will have to, one way or another, have some sort of wallet to interact with the system, although it doesn't have to be a web extension. There's also this thing called arweave.app, which has like an embedded iframe type wallet system, and a username and password login. So it feels like normal user accounts. But one way or another, they have user accounts. So this is actually kind of cool. When you're building these applications, you realize, oh, wait, now I don't have to do user auth anymore. It's almost like OAuth, how that changed web application development, but just for crypto stuff. So instead of it being like, now everybody's even more dependent on that Google identity, they're less dependent. Actually, they have their own sort of sovereign identity, which is pretty cool. Instead of using backend databases, just use GraphQL. So you can build queries like this. This will say, hey, get for me every transaction sent to the network, which has content type text or HTML, so it's a web page, and the user agent, so the thing that uploaded it was this Arweave auto decentralized public library bot. Cool. So that's just going to return to you the list of TX IDs, and then in this edges part down at the bottom, you can put, right now it's just going to return the ID, but you can say, the sending address, how many tokens it sent, price, whatever it happens to be. You can get all of the information out of that. So this looks a bit weird if you've never done GraphQL before, but there are lots of resources out there about learning how to use GraphQL, and it's a pretty standard process at this point. And if you already know GraphQL, all you need to know is this new schema, which is fairly well outlined online. Deploy your application when you build it with Arcbee. That's just a one-line thing. So you just install via yarn or npm or whatever it happens to be. Arcbee, this deployment tool, and then just say Arcbee deploy your directory, and then use a bundler. And if you do that, you can do it for free. So you don't even need any tokens to do this. This will just work up to, I think, 300 kilobytes, something like that. And just deploy the thing. Or you can use Argo, which is a simple way of deploying applications onto Arweave, which plugs into your GitHub, CI framework, basically. Okay, so then how should you govern your application? Well, you can actually just embed this system called community.js, which is kind of like a DAO in a box, if you will, into your application if you want to, and then spin up a new community, which there's like a function call for each, whatever it happens to be, like a subreddit type thing, or maybe you want spaces on a Twitter system, which is what MetaWeave does, which I'll show you in a second, or anything like that. If you want community governance of an area of your application, you can just use the JavaScript calls in the system to do it. And it all runs inside SmartWeave, which is Arweave's smart contracting system, or a smart contracting system on top of Arweave. There's actually like 3 or 4 now. Yes, but it all works like seamlessly in the browser, and it feels smooth and normal for the user. Okay, and then you just have these votes. So they're saying things here like set the fee to this or that, it's spawning an airdrop. But you could also imagine it's very easy to do something like set the featured video in our community to this identifier for this period of time, or something like that. And that can really, the community could govern the areas of the application just as they want. And this is how you install it. And it's super simple to get going with. Okay, so that's a little bit about Arweave, how you can build on the perma web. And now let's take a look at one of these applications. So this is what they look like. This is served from arweave.net, but you can serve this same TXID here from any permaweb gateway. And all of this content itself is stored on the permaweb. So you can see this is in reply to some other TXID here. And we can just say, hey, buildspace. And we just say leave it. And then this will generate a transaction for us. I'm not sure what this application does that causes this slow processing, but it doesn't need to be this slow. It's normally pretty quick. And there you go. It's actually, I'm already logged into my Arconnect, and I've said that this application should have a, it should have a, what would you call it, an allowance. So it can send transactions up to a certain price for me without me having to press the buttons that you'd expect in a normal Ethereum-like application. The reason we do this is because web applications are just so much more interactive, if you will, rather than smart contracts where the interaction speed is much slower and much higher value. When you interact with a smart contract, it might be worth like hundreds of dollars, if not like thousands or tens of thousands, millions of dollars. Whereas me pressing this like button is not a high value transaction. And so, yes, we have the system whereby you can say, okay, when you start this application, please, set an allowance of 0.1 R or something like that, like $3 today. Good song for the day. Video unavailable. Great. Yes, and that's probably how the system works, and it has this smooth experience, which is just like a normal web application. Like you wouldn't really know that this was running in a fully decentralized framework unless you saw the details. But you see here it says my Virtual ID. So how it's extracted this data is that it's not that the MetaWeave developer had a special profile system where they, it said all these attributes. Actually, it got my profile picture here and my name just from Virtual ID, and I'm not sure where this takes us, but you can also see here, this has just plugged me into virtual.exchange, which in the backend is actually a Perm web application, but hidden with the URI. Yeah, where I've set my identifier here. I think I actually even did it with Arconnect. But all of that information is available to every application on the network, just as a result of the data being open. And so I think there's like this, let's see what is happening on the Open Web Foundry here. So I'm not sure how far they got with this, but one of the new application features that they're working on with MetaWeave is community governance of these spaces. So it's not, oh yeah, maybe if we, not sure yet. We might be able to take this into community.xyz. Let's give it a try, see what happens. XYZ. And see this community on community XYZ, yeah, that we refer to. So we'll go to something else first and just see, okay, change this to that other address, get rid of that. This may not work, but we'll find out. Is it loading or is it just not going to work? Okay, never mind. Well, somewhere in here, there will be a community ID, and we can look in the back end of that and see how they are governing this space. So I believe that MetaWeave wanted to make it such that these images here are things that you can change, as well as the name and that kind of stuff. Oh, is that a link there maybe? Okay, live demos, not working. But that's the broad principle. Yeah, there's a ton of stuff that you can do with this. I guess I'll just leave it at that for now. Maybe there's time for questions.
Hey, thank you so much for that. Oh, the applause came up. I thought that feature was like not really real. So yeah, thank you so much for showing that. So one of the things I found really interesting about Arweave, and correct me if I'm wrong, as a summary. So like, for example, those of you who have been on Twitter or Facebook before, I guess in crypto, most of us are on Twitter. So like you have Twitter 1.0, but today if Twitter decides to go to Twitter 2.0, then we don't have a choice. But but if it's built on Arweave, the beauty of it is that we can all stay on 1.0, and you can still have Twitter as a company, and Twitter will have to convince us to either go to 2.0 or build, I don't know, 2.5 that is way better, right?
Right, precisely. Yeah, there's a, I was going to call it community governance, but it's not community governance in the sense of DAOs. It's more non-coercive updates is a fair way to put it. So you just can't be coerced into using a new system if you don't want to. You can always use the old system, and subsequently the power relationship between you and the developer is like fundamentally different, and I think better. Yeah.
That's really interesting. So somebody asked, I kind of see this question popping up a lot is how would Arweave manage, when you start to get to really large data sets?
Yeah. So the cool thing about Arweave, okay, there's two sides of this. The first, okay, good. Protocol layer first. So actually, Arweave scales unbelievably well, and I know everyone in crypto says this, but we actually have a very, very strong claim to that. And the reason is that Arweave has, I think, its weird niche, just so happens in the design space of blockchains, where we can have an extraordinarily scalable system without it being too complicated. So Arweave is like one contract, which is the endowment, and then one Merkle tree for all of the data in the network. And when you add data to the network, you're just adding to that one Merkle tree. And then, yes, we have transactions, and so you have to adjudicate, payments, and that's kind of traditional blockchain-like system. But we realized, and so that has scalability throughput, limits. But we realized that what you can do is you can just bundle transactions together, data together, essentially, and commit it all as one, because it's all permanent, right? And it's all paying the same, essentially, same price at the base layer. You can have like these bundling services that you have a balance with, and that balance can be super small, so you don't have to worry about security of it. You can have this balance with the bundler. You can send your transactions to it. It will bundle your data with other people's data, and then submit that all at once. And that is only using one of these, would you say, scarce slots over time of, like a transaction placement. But you might be actually entering millions or even billions of transactions into the network at once.
Right, yeah.
So that's pretty exciting. And it means that essentially over time, what happens is people are incentivized to bundle their data together with other people's data rather than increase the fee per byte that they're paying.
Right.
And so then between the bundlers, which can also recursively add data to each other's stuff, by the way, you get a market where the bundler is offering a service which is at some premium from the base fee. And you just want to go to whichever bundler is offering the lowest premium on the base fee. And how does the bundler achieve that? You just bundle it with other people's bundles. And so this is really kind of nice. And then at the other layer, which I think is also important, it's like, well, how do you, if you will, animate the applications at scale? I think there's many, many different ways you do this. Like there will be some generalized behemoth gateways that are looking at indexing basically all the data as close to that as they can, which is probably going to be quite slow. But we're also expecting to see application-specific gateways or data protocol-specific gateways. So I know someone said something about LinkedIn in the chat. Well, if you had LinkedIn's data set, then you could just index just that subset of the data on the network if you wanted to. And then there are these kind of like gateway swarms, basically, where you can aggregate results from different gateways together, and you have this nice latency-based reward system for that. So it's actually a very simple mechanism again. What happens is you can top up with a certain set of gateways as a gateway yourself, and then you can forward requests when people send them to you and you're being paid to answer those requests. And then you just top up only with the gateways that respond with useful data, so data that other people aren't giving you perhaps, in a timely fashion. And then you sort of fashion the set of gateways that you are aggregating from to be an effective and cheap set, essentially. And then you can provide that to your users, which also recursively might be other gateways or other end users. And this is a nice system for incentivizing people to return with useful data quickly. Confess handling transactions. But what if I need to access this data? Yeah, well, that's what gateways are for.
Right. One of the things that I really like, I think about blockchain in general, but especially the GraphQL with this is that I come from a more statistics data sci background. And I love the fact that now I don't have to rely on, I'm not gated to access a lot of data. And like you said, that I can just go look at Mirror and do a spinoff immediately. Yeah.
Right. Yeah. It's it becomes about the clients to data protocols. So I think actually Twitter, like that application I showed you, Public Square, was was using a protocol that I designed on Twitter, ironically, in like 3 tweets. It's very, very, very simple to define the data protocols, and then the clients on top of where the real value sits. And so there's competition to build the best clients for shared data protocols underneath, essentially.
Right. Somebody asked kind of how to learn more about gateways, and do you mind just kind of taking a few minutes? So actually after this session, a couple of people and I, we're gonna teach the community how to build some stuff using. I know that on our wiki has some projects available.
Yeah.
Can you kind of just mind showing us some of the projects we can go build immediately?
Go build immediately. Yeah, I mean, I would say the Arwiki. Oh, you guys can't see my screen anymore. Okay, I was gonna. But yes, go to arwiki.wiki. There's a great tutorial about how to build a decentralized public square on top of Arweave. I would say that's a good place to start. Actually, Arwiki itself is in fact served on the kernel web. It's just using Argo to mask the the DNS name resolves at some point to a TXID underneath.
Yeah.
About gateways. Anyone? Yes, someone asked something about that. Can anyone create a gateway? Absolutely. So there are probably like 6 or 7 different flavors of gateway on top of Arweave right now. There's this one big behemoth one, Arweave.net, that most people use, but there's also, like application-specific gateways. So Mira runs one of these. Before that, they had one called FeedWeave, which is kind of like the prototype version of Mira, I guess. And then there are others that are like much more application-specific, like very far deviating from the typical feature set you'd see from a gateway. That's stuff like Redstone are running one for their contract system. But yeah, anyone can build them.
Cool.
They come in all shapes and sizes.
Sam, do you mind trying out something? So I have this giant table in the back of the cafe area. I think maybe we could like migrate there and just kind of let people pop off and chat. I want to be respectful of your time, so I'm sure that if you have to go have a hard stop, we can definitely stop as well.
Yeah, I have like 10 minutes or so. That'd be great.
Do you guys all want to just hop back to the cafe area? Just go ahead and head there.
One thing I will say to everyone while we're here is, if you are interested in building on top of Arweave, we have this sort of investment program we run, basically, where if you want to get started, we take you through the whole process of like from zero to building your first Hello World application, which it looks like you can do basically today, all the way through to like getting your first external investment, and along the way we'll invest $100,000 in what you're building. It's very egalitarian is the idea, so we really just look at outcomes. If you manage to build an application that's
the Open Web Foundry.
No, this is actually slightly different. It's a new thing we're running called Arweave.build.
I see.
That webpage has all the information you need. Some of the people that graduate from that will go into the Open Web Foundry, but that's kind of optional. So yeah, if you want to check that out, that could be interesting to you, I'm sure.
That's fantastic.
All right, let's go to the tables, I guess. Thanks, everyone.
Even if you can't get a seat, that's perfectly all right, because you can stand around. Here, I'll give up my seat. Somebody can sit there.
So are we asking questions like this or in the chat?
Yeah, go ahead.
Just speak. Yeah, go for it.
Yeah.
Okay. I'll wait. Sam, over here.
Hey, Tom. Yeah, I can hear you. You don't appear to be able to hear me.
Go ahead and ask your question. Yeah.
Yeah, I just wanted to, I didn't know if Sam had made it over yet. Question I have, Sam, is about content moderation. I know that people operating storage nodes are allowed to essentially say, I don't want a certain type of content stored on my equipment. How does that work, and yet at the same time allow for real censorship resistance?
Well, I think actually that's ironically the only way that you get censorship resistance. And the reason for that is that you can't force people to store your data, even if you didn't give the miners, so the storers in the network, choice about the. Sorry, we got this like really loud sound effect of the cafeteria. There's no way to turn that off.
That was supposed to
Can
be
I?
for ambiance. I'm gonna turn that off.
It's very nice ambiance. It's just a little bit distracting. Sorry, but okay. So that is the only way that we think that you can get censorship resistance. And the reason for that is that simply if you're forcing people to store information that they don't want to store, they're just going to go elsewhere. They're going to go mine Chia or whatever, which doesn't have any like useful data storage, and subsequently no one's data would be stored. So you can't coerce people into storing stuff they don't want to store. You have to be kind of like you say open to the ability to them to choose what it is that they store. What we can say though is that everybody's incentivized to store every byte, but they don't have to take that incentive if they don't want to. And that's actually also really important from a legal perspective. They have to be able to run these nodes in countries where, for example, China, where like half of the data set is not going to be admissible by the local government. And it's just not feasible to run a network like this where you don't allow people to do that. But what you end up with is sort of meta governance, which seems to be the closest we can get to what everyone wants. Like everybody seems to want censorship resistance, but everyone can also agree that we don't want to store like real abhorrent data that is illegal everywhere in the world, right? So if it's illegal everywhere in the world, then while everyone is incentivized to store bytes that might be related to that, they're also massively disincentivized by their local governments, which we all agree is a good thing, from storing that data. And so what you essentially get is, well, if the data is not illegal everywhere in the world, someone will probably store it. And you also get this interesting effect, which is the more well replicated a piece of data it is, so the more willing people are to store it, then actually the easier it is to find. So there's like, at the base layer, there's, well, look, if it's legal everywhere, no one is going to store it. And actually everyone seems to think that's a good thing, and I would agree with them. And then on the layer on top of that, there's like, okay, and if it's data that almost no one wants to store, well, actually it's really pretty difficult to find in the network. It's very slow. It's a trade-off, but I think that that's probably the most reasonable way of doing it. And also thinking from the point of view of the people engaging in the network, it's actually the only way that I can think of doing it that will actually work. Like if you start trying to force people to store data that they don't want to store, they're just going to go do something else with their time. And then you have no network at all, right? So that's not censorship resistant. That just doesn't exist. Does that answer your question? Tom, I think it was.
That answers it for me.
Okay.
Can you hear us, Tom?
Yeah. Hi, Sam. I had a quick question.
Finally,
when we store any data on Arweave, what's the guarantee that the data is to be there in the case of, let's say, let's say there is this one node which currently hosts some amount of data from a company or anyone that I'm working for. And let's say that node or that particular person surprisingly decides to shut down the node and maybe, some way the data gets corrupted. So what's the way to make sure that the storage of data is available at every possible nodes and the way that the data is always retrievable, right? What's the guarantee of that?
Yes, of course. Yeah. So we actually don't think that you should go this route that I've seen other storage networks go of assigning data to people for this reason, because you can never really make the collateral high enough that there's actually a sufficient disincentive from just switching off your node. And the reason for that is that the storers have to store huge amounts of data. And subsequently, if the collateral was really high enough to disincentivize them from switching off their nodes, it would actually be too expensive to start mining. And so like you see, some of these other networks, they have like 30 cents or something per gigabyte. It's not enough. Like grandma's photos might be only a few tens of megabytes, but she's gonna be really, really upset, more so than like 3 cents worth of upset if they get lost. So that's not great, I think. You have to go from the other direction. You have to say, okay, well, everybody should be incentivized to store the data. They should be more incentivized to store data that is less replicated, up to at least some certain point, so it doesn't get too extreme. Then you get an auto-leveling effect across the network, where people are incentivized to work out what is less replicated and go replicate it such that they're more likely to get a mining reward. On top of that, we make sure that there's just a very high level of replication in the network to begin with. So at stasis, or like the steady state, it should be running at about 45 reps per piece of data. But right now, because there's an inflation reward as well, then it actually over incentivizes. And so we think it's into the tens of thousands of replicas of the data probably at this point.
So is there like a special setting maybe that let's say for me my data is something that I really want to make sure that is replicable at multiple places. So is there like some sort of special setting or some sort of instructions that I like give to the network to make sure that my data is available at multiple points and there is no single point of failure?
Well, you're by default, when you put a piece of data into the network, you're paying for it to be replicated in 45 different places at minimum. So it's pretty damn well replicated. Yeah.
Thank you.
Of course.
I have a question. So, like you took an example of Mirror, right?
Yes.
Why are companies like Mirror incentivized to create an application, because anyone else can copy their data? So essentially, if I make a better Mirror, I essentially get all the users to my website. So why is someone incentivized?
Yeah, so that's an interesting question. There's these like adversarial incentives for developers. And I think the answer comes down to, well, the users to some extent want to own their own data one way or another. And this is a way of enabling that feature. It also goes the other way. So when you're bootstrapping, you want to connect to this network because it has all this data to begin with. And so you, what do you say? You benefit from it, essentially. I think that there's questions about how you monetize that data, which is probably the real answer here. It's about associating, as Mirror does, NFTs to their data. So in Mirror's case, they're very happy for people to come along and use the Mirror data set, because it's actually just making the NFTs that they're issuing on top of that data, more prominent, and subsequently more prominent probably means more valuable. There's lots of different theories in that area, though, and it is an interesting question for sure. There's also other ways you do it and say, well, okay, I would rephrase the question a little bit, right? Like, monetizing the client is easy. You just build the best client for it, right? But the question is more like, how do I capture the value of the data protocol that I've created? And one of the answers is, well, the data protocols tend to be super simple. Another is, well, so do you even need to monetize it? It's like an hour's work for most of these things. Another answer is that you do it somehow through monetization, like NFTs or profit sharing tokens on top of that data, and then through your client or whatever it happens to be, you take a very small quantity of those profit sharing tokens, and you distribute them to your shareholders, token holders or stakeholders, one way or another. That's one way of doing it. Another way of doing it is to make libraries for that data protocol, make them very, very cheap to use, but make them paid. So when you want to upload a piece of data to public square, someone built a JavaScript library for this, and it's really easy to do using the JavaScript library. You don't have to interact with GraphQL directly or even with Arweave.js. You just say new post, go send it, cool. Then like 1 in every 10 times, it sends a tip to the stakeholders of the people that made the library. So there are a bunch of different ways of monetizing data protocols, but it is for sure like an open area of research. I think ultimately it comes down to a wider question of, well, why would you ever use an open standard or an open protocol? The answer is operability. Interoperability is generally a net positive thing in many areas, at least. That's a bunch of different answers, but yeah, it's an open, interesting area. I think there's lots of different ways you can handle it.
Thank you.
I actually find that answer very interesting, because one of the things I kind of feel like, since we're all gathered here, we might tend to have a bias towards everything needs to be on the blockchain, but you probably don't think that everything has to be on the blockchain, right, Sam? Or do you think so?
Right. No, I see it less about being on a blockchain. Like, I see decentralization in the technology as just enabling us to do things. And what would you say? Like, I don't care about the means as much as I care about the ends. So for example, like I see all these people like, oh, they're very upset about decentralized ownership of tokens. Like, I don't care about this even slightly. I care that the protocols don't care who owns the tokens. So I don't care if MicroStrategies has like, 1% of the Bitcoin in the world. Like, doesn't mean anything to me. I'm very happy owning my 0.00001% of Bitcoins or whatever it is, because I know that the protocol isn't going to change just because those people have those tokens. Yeah, so I think that the technology we use is a means to an end, and in a similar vein, you could say that applies all the way down the stack, right? So it happens to be that a blockchain is sort of the right tool to make these applications have these properties. But if there was another way of doing it, we'd probably go for that route. And the kind of wider question, I think, is, or at least more Arweave specific question, is like, well, is permanent data storage suitable for everything? And I think the answer is that's absolutely categorically not. No, of course not. There are some pieces of data that really should be around forever. Like, if you put it publicly on the internet and you're trying to publish it and maximize the number of people that see it, then high likelihood you want that thing to be around forever if it can be. You just didn't have the option before. But there's also stuff like instant messenger chats, that kind of thing, that we want to be purposefully ephemeral. One of the things we were thinking of in the early days of Arweave is, because people always assume that we have this like bent that every piece of information should be publicly permanently available. We absolutely don't. Whether we should put some time and effort into building an anti-Arweave in some sense, a sort of deliberately ephemeral network. And we did do some sort of modeling of what a mechanism for that might look like, but it turns out it's actually much harder, we think, to make a provably ephemeral data storage network than a provably permanent data storage network, or rather permanent with some very obvious, clear economic basis that everyone seems to be able to get behind.
Ghostweave.
Ghostweave, yeah, that's a great name for it.
Yeah, I mean, you probably need to leave soon, right? So if you,
I can go for like a few more minutes. But
yeah. If anybody else have any questions, I personally have a question. One of the things I find really interesting about Arweave is that the loss of knowledge. And so I always kind of thought of like books as being an example of physical decentralized objects. So like you have books that are published and they might go out of print. However, if they go out of print, it doesn't mean that you can go out and publish that book, because somebody might still have the publishing rights.
Right.
You can still access the books, but it's very, very difficult to go and find the nodes or the people that own these books, right?
Right.
So
yeah.
I find that to be a really interesting analog to the physical reality. And I kind of thought like an example would be Moby Dick. I think, Moby Dick is now a classic in American literature, but when it was first published, there were some threats of nobody wanting to read it because of the religious content, but it wasn't until F. Scott Fitzgerald in the 1920s who rediscovered it and popularized it. So I kind of thought, well, there could have been an alternate reality in which there are all these nodes who have a copy of this decentralized data unit, but there's no way to query it, and I can't even go out and publish it because I don't have a publishing right.
Right.
Yeah.
Well, I mean, that last part is particularly interesting because it's sort of a blocker, if you will, on the redistribution of that data. But it reminds me of in the archiving world, there's this concept of, well, if you want to store a piece of data for a long time, what you want to do is make lots of copies of the information and hide them in many places across the world such that it's not easy to discern where every last copy is. You don't want them all to be addressable. You want like 80% of the copies to be addressable. And that was something we were thinking about a lot when we were building the mechanism for Arweave. And one of the cool things we've noticed is when miners switch off their machines, they don't typically delete the data. So you get these like replicas of the data set that are made and spread across the world. But there are probably like, at least thousands of these now that are offline. So they're still, available. Someone can bring them online later and recirculate that data, and they actually have an incentive to do so. But it just adds to the resilience and the sort of redundancy of the system, that some of them aren't publicly addressable. If you want to go on like a data killing spree and try and remove every last copy, you wouldn't even know that these exist. They're like hidden in someone's drawer somewhere. So that's one of the like elegant parts of the mechanism. It's this weird spidering effect of it. It incentivizes all of us humans to just keep making replicas of the data and hiding them in random places.
Yeah.
Dead Sea Scrolls, right? Yeah.
Well, thank you so much for coming out. I know that a lot of people really enjoyed this. We're very excited for this talk. Yeah, and I think we're going to go out and build an Arweave project together soon. So thank you very much again.
Amazing. All right. Yeah. Well, yeah, I'm very excited to hear what you guys get up to. And check out arweave.build if you think it's something that might be interesting to you.
Yeah.
Amazing.
Thank you very much, Sam.
Thank you, everyone. See ya.
See ya. All right. Thank you for joining us. And I think you guys are free to like hang out a little bit longer. I reserved this space until 1:30. Anybody have any questions?
Yeah.